Ladies and gentlemen, I believe that we have begun. I think that it's Thursday, April the 9th. I'm going to date this. I don't know why. I mean, you don't have to watch them in order, although I do kind of string this out in order. And you have come to the OscopeWizard, and I really appreciate you joining me today. I have messed with the microphone trying to get the levels right. I hope that everyone can hear me. I have added what is called a noise gate, so hopefully you don't get that annoying empty sound of silence in the background when I'm not speaking. You'd really think I'm better at sound engineering on this show because I spent about 15 years doing music and being a music producer. So I should really know what I'm doing, but it's like so much coming at you. There's cameras and lights, and I just realized I forgot to turn on my light, so hopefully you guys see me. But we are going to work a little bit more on my Minecraft server. So in the last episode, we tried all kinds of different ways of powering my Minecraft server with cell phone adapters, which is pretty common because I'm using a single board computer very similar to a Raspberry Pi. It is called an Asus Tinkerboard. You can see it right here. Right here. Boop. There it is, Asus Tinkerboard. Looks a lot like a Raspberry Pi. Plugged right into the power supply there, my NGL202 power supply from Roda & Schwartz. I also have an RTO2044, also called the RTO2044. That's what the insiders call it. I just let you in on a little secret right there. You know what? Before I get too far into this, please, everybody, if you can hear me, just type into the chat and say, yo, man, I can hear you, OscopeWizard or Gabe. I go by both. On the show, I'm the OscopeWizard. In real life, I still have to use my alternate identity of Gabe. One day, maybe I can blossom and be free. So I thought that I'd do a quick recap of the last episode and then move on to the current episode. All right. Thank you, guys. I appreciate it. I can hear... Yeah, or you can hear me. I mean, I can hear me because I'm sitting right here, but I'm glad that you can hear me as well. Thank you so much for letting me know. Let's begin this episode where we ended the last episode. In the last episode, I talked about the things that I wanted to do. I wanted to power our Minecraft server, which we did. Nailed it. Now I want to get to the part where we actually log the power while playing the game. We actually never played Minecraft last time, and that was a real bummer because while I don't like Minecraft, my son loves it, and from what I understand, it is a fairly popular game. In fact, a lot of my coworkers play it, and they have set up all kinds of elaborate servers, and so it is a wonderful game to play. But then, after we log the results while we're playing, I want to check the results and see what they look like, which will be a little bit more serious because that's going to involve some spreadsheets and some graphs and charts, and that's not really my strong suit, but we'll see how I handle that part of it. So to recap what we did last time, I had my oscilloscope plugged in, and before you use an oscilloscope, I see a lot of other people also like Minecraft. I agree. You should play it with your kids if you don't play it with your kids. Give it a try. It might be something you like. So back to the oscilloscope. First things first, pro tip. The first thing you do when you sit down in front of an oscilloscope, in general, any oscilloscope, honestly, before you use any piece of test equipment that you don't know the provenance of, you should hit this button. This button is the preset button. Presumably, hopefully you can see me hovering my mouse over the preset button. I'm gonna hit preset. And the scope now is preset. Thank goodness. Oh, somebody's excited to see Minecraft on a scope. Hey, here we go. So we need to find that signal. So I'm using my scope the RTO2044 with a ZPR power rail probe to look at the power rail because I'm talking about powering my Minecraft server. So let me turn on this handy dandy probe meter that's included with my power rail probe. And I don't have a signal on the screen right now. And magically, vamoose, abracadabra. Vamoose feels like go away. That's not right. Abracadabra, alakazam. What did they say in Alibaba and the 40 Thieves? Open sesame. I think it was open sesame. Whoa, we got a big spike over there. Right now I'm probing the power rail probe. Can everybody see the power rail on the signal on the screen? It's 5.14 volts. If I look at the setup, you can see that I have set my power supply here to, can everybody see my power supply? To 5.1 or 5.2 volts. So let me change this to 5.1 volts. And now the oscilloscope over there in the corner is reading 5 volts. And so let's copy that offset and bring the signal back to the middle of the screen. You want the signal in the middle of the screen. So, whoa, my camera's doing wild stuff. Hello, camera. That's because I don't have a real light plugged into it. Don't tell anybody. If my boss is watching, I apologize. I'm usually very good at this, but not today. So this is the power supply powering the Minecraft server, and we're using the front outputs of the power supply. But the last time I said that there was a way for the power supply to actually measure the voltage itself and keep it locked at a 5-volt rail, because I keep having to mess with this voltage right here to get 5 volts here. So in order to get 5 volts here, I'm having to output 5.1 volts from the output right here, because I'm getting some kind of voltage drop across this long cable. Well, that's a bummer. Boo! So I can actually plug in, let's see if I can make this work through the magic of television. Plug in a cable into the back of my NGL, and in the back of my NGL, I have a couple of signals back there called sense lines, and those travel along with my voltage lines, and they come up to my Raspberry Pi, or my Minecraft server, which is actually an Asus Tinkerboard. And if I go back to my setup, I can see that I've made a quaint little adapter here to plug everything in. So let's do that and then actually log some data. And while I do that, I'm going to take a quick break to plug everything in. I am Serious Gabe, the serious OscopeWizard, and I think regular Gabe has a little bit of trouble with numbers and figures and charts and graphs, and honestly, I think he is scared of Excel. So, data logging is a serious business. That's why I'm here, to do serious things. So let's get down to business. I believe he has plugged in the power into the back of my NGL. Let us see if he has it correctly done. I now have my cable connected via this cable, which is in turn connected to the back of the NGL. I am logging data. Actually, I am outputting power. Let us see if I can make this data log work. I want to play a little Minecraft in a very serious world. I am going to plug in this USB stick, and that is what I'm going to use to log the data. Normally, power supplies from other vendors and other pieces of equipment require extra software, which can be a bit of a bummer, if I'm to be completely honest with you. And this solves that problem by using a simple USB data stick. Very seriously. Can people still hear me? I hope so. My children think that this is a very funny accent. I am not completely certain if it is. Now, I believe that my Minecraft server is now booted up. So, can everybody see my finger? It is right here. Thank you. I see people do hear me, which is good to hear. Now, I will use the setup menu to turn on data logging. I am logging data. Seriously, I am doing that. Let me minimize some things on my screen, and let us go over to my screen where I have captured some data from a Minecraft session that my apprentice played over the weekend. He and his friend used this Minecraft server to play a game, and you can see this is the data log from that game. There was a question of why did the volts go down from 5.1 volts to 4.9 volts. That is actually a very small change. And in fact, many engineers would consider 4.9 to be 5 volts, although serious engineers would want to know the difference. Generally, the voltage drops when the current spikes, because it is very hard, without using sense lines, to make that all work correctly. But using sense lines, as the current rises, the power supply can actually compensate for this current inrush, or outrush as it were, and pump the voltage up temporarily. I hope that I have answered your question satisfactorily. So, while I have the USB stick plugged into the NGL, I want to open a Minecraft window. Before I do that, did everyone see the data log? So, if I were to look at this data log, I can see that the Minecraft server remained fairly quiet for much of the day. This is because my apprentice was not allowed to play Minecraft until about 2 in the afternoon, at which point you can see he had quite a rollicking good time with his friend online for a few hours and then dropped off. So when he is in the server playing the game, the current spikes up because it requires more power, and the voltage remains rock solid because I'm using my sense lines, and the voltage does not drop. You are powering a server from the power supply. I am using the power supply to power a server, which perhaps might not be completely usual, but in the wizard's household, in the land of Nod, it is something that we do all the time. Let us open up a game of Minecraft ourselves and see what happens to the power. I will open up a Minecraft multiplayer game, connect to my server, hit join. Let's go over to the setup screen of my power supply, and you will notice on my power supply that when I connected, my current jumped up to 1 amp, over an amp in fact, because now I'm having to actually simulate a world on this tiny server, and the power supply is having to give it a little bit more juice. I, myself, am not very good at Minecraft because I'm a wizard, and who cares about silly, frivolous things like Minecraft when you're a wizard? But I will play for a moment. You can see me playing down in the bottom left of the screen if you squint your eyes. Hopefully the younger viewers at home can actually see it. And as I move around, you will notice that the server is drawing different amounts of current as it has to re-render different sections of the map. So as the game map rendering gets more and less complicated, oh my goodness, and I timed out because I believe that my server crashed, which happens. Unfortunately, this is a live stream, so it is very hard to recover from a thing like that. But no matter, I believe that we have logged some data. Let's go back to my setup screen. Oh, I think I'll turn off the data logging. Open up this thumb drive on my computer. And this is where it gets very serious because now I'm dealing with numbers. And numbers are very serious business. So, today at 11:14 a.m. Eastern Standard Time, I'm visiting from the land of Nod, where it is not anything to do with Muggle time. Let's delete this. I'm a little new to this program. And I want to... Where did my window go? There it is. This is why I'm here, for serious business. Let us drag this to the corner and make a chart from this data. So I want a line chart because I would like to graph lines. And now, can everyone see my Minecraft session? It would probably be easier if I made it larger on your screen, and I believe that I have. The OscopeWizard's mother says she needs a magnifying glass. I believe that is called a seeing glass, and she should probably purchase a nice one at her local commissary. But the OscopeWizard's sister can see it because her eyes are a good sight younger than her mother's. So here you can see the server was quiet for a bit as I began the session, and then suddenly the server jumps as I am playing, and you can see that I jump up to nearly 7 watts, which is the measure of power. Voltage times current is equal to watts, and that is why I'm here, because numbers are serious and math is serious. If we watch, you can see where the server crashed right here and then went offline down to here, and as I unplugged it, it was trying to boot itself back up. All this with data logging, which is very exciting. I believe that my time here is finished, and so I must say goodbye. This great!
I can't believe I've turned myself into a teddy bear again. I've got to...
Hey guys, I had to get out there for a second. Did anything happen while I was gone? Did I miss anything? Hopefully I didn't miss anything. It's, camera's a little blown out. That's weird. Let's turn that down a little bit. I think I hear footsteps on the stairwell.
5 minutes left!
Uh-oh, guys. I only have 5 minutes left, so I better wrap things up. First of all, we did some data logging. We did data logging using just the front of the oscilloscope. We did data logging on the oscilloscope because every time you use the oscilloscope to capture data, you're actually logging the data into the memory. And then we used the NGL itself to log the data into a CSV file that we have on a thumb drive. And I'm sorry that I missed it. Hopefully it worked out. It was weird. Suddenly I heard like this evil voice and I was teleported somewhere else, and now I'm back here. Wild trip that I had there. Before I go, I wanted to say a lot of thank yous. Thank you so much to my family for watching. Thank you so much to my buddy James the bald engineer over at Add-Ohms, for helping me figure out how to do all of this. If you haven't checked out his channel on YouTube, please look it up. Add-Ohms, ADDOHMS, ohms. That's an engineering term for resistance. Also, thank you so much to Gianmarco at Batterfly for letting me visit some of his webinars, and he even sent me a great gift, and I really appreciate it so much. Now, I believe that my time is done for today. I'll stay on and answer any questions in the chat. Otherwise, join me on the next episode next week on Tuesday at 11 a.m., and we will talk about magic wands. Pretty cool, right? Bye, guys.